Some people would say too many monitors isn't a thing. They have these monitors all over the place. It's like, I think it's like two good sized monitors. I'm happy with. I mean, when I get to if I go over 27 inches, I find my head moving too fast. So it's like, but then you got to bump the font size up, so it kind of mitigates it. It just looks cooler to have a bigger monitor, doesn't it? You want a 45-inch monitor in front of you. Nah, screw that. 65 inches. Um, okay. So, how's everything going? Well, so far? Enjoying Antler? It's cool. It's different. I mean, the thing with Antler, one of the things with some of the stuff we're doing in this class. Whoops. Is we're talking about declarative programming as opposed to imperative programming. And with imperative, we're basically giving a series of instructions on what to do. With declarative, we're basically saying, when you see this, do something else. Or here's what I want to do based on the way something looks. So very, very useful. And that's something I really like about Antler. I wrote a tool a while ago called Answer, ANTXR, which was another tool for XML recognition. I based it off of, was it 3 or 2? I think it's off Antler 2, so it's a really old tool. But in the tags, you basically, or in the rules, you basically specify XML tags instead of rule names. And you'll say this XML tag can have these children, and then it'll run the parsing the same way that Antler runs it, just reading from an XML file. And you could use a SAX front end or a Stax front end or a DOM front end for it. It was kind of a fun tool. I just haven't touched it in years. So every once in a while I get an email from somebody saying, it's not working. I'm like, it's like 12, 15 years old at this point, and I haven't touched it. I'm sorry. It's abandonware. What can I say? But it was fun when it lasted. Today we're going to talk about xtext and using it to generate an IDE and some wonderful models. And let's see what else. Some validation. We're not going to do code generation today. We're going to talk about that next week. I think that this will be more than enough for this week. And what we're going to do with xtext runs inside Eclipse. You can use it. Question or? Oh, just okay. You can use it to, once you've created all your stuff in Eclipse, you can use it outside of Eclipse to run your parses, to load your models, things like that. The IDE use outside of Eclipse is very, very limited. They originally, well, not originally, but they added in IDEA support, but they had a lot of problems with it. They ended up having to use a lot of internal APIs inside of IDEA, and the IntelliJ folks kept changing those APIs. Internal APIs, you got to expect they're going to change. So they got kind of fed up with that. So what they did is instead of supporting that, they supported something called the Language Server Protocol. And this is something that Microsoft came up with for having editors that can have pluggable language servers. So this way, somebody could create a language server for Kotlin, for example. And then any editor that implements the language server protocol could use that exact same language server to get all of its content assist features, to get its formatting, code highlighting, things like that. So they decided to go this way, and IntelliJ has been really slow to adopt this. There is a plugin for it, and depending on how much time we have, I might show it to you. It's kind of clunky. It doesn't give any type of syntax highlighting, and the content assist is flaky at best. I'll show you inside Eclipse what it looks like. I mean, everything's really nice. You have code highlighting, code formatting. You can customize the highlighting and the formatting. You can do cross-references between different types, scoping, and validation, code generation. Everything inside Eclipse is just fantastic. So this is a possibility, but we're going to focus inside Eclipse. Now, obviously, if your projects are already in Eclipse, this works great for you. You can just create new projects that are xtext projects, use them as dependencies. You take those xtext plugins that you've generated to feed into a new Eclipse instance, and then inside there, edit your models, have it generate code for you, have it load code, whatever. We'll see how some of this stuff works. Xtext behind the scenes uses ANTLR. But there are some limitations on how it uses ANTLR. The grammar that they use in Xtext, they're using not only to generate the grammar that describes the content, but also to generate model classes. Every one of your rules, they think of as a model object. And in ANTLR, when you had those little labels to say this ID has a certain label on it, that actually becomes a field in the model class for you automatically. If you reference other rules, those become lists inside the model object. So it's a really nice framework for just, boom, I have my model, get my data, do something interesting with it. So we're going to walk through a couple different types of examples on it. One of the examples is going to be the state machine from the first day. I'm going to do a slightly different version. The one I showed you the first day used code generation. This one we're actually going to use it to read a model in. And then we'll also take a look at that expressions language. The expression language is where things get a little bit stickier with Xtext, but only because we've already seen in ANTLR 4 how you can take advantage of the automatic left factoring. So we have that expression rule where I can say expression is expression times expression or expression plus expression, that type of thing. Those are called left recursive rules because the very first part of an alternative is the rule name itself. And in a recursive descent parser, which is what ANTLR does, all those rules become methods. And references to other rules become method calls. So if the very first thing inside your method is a call to itself, you got some trouble. There are fortunately some nice ways to factor that out into a bunch of subrules. ANTLR does it all behind the scenes, but we have to do it by hand. It's not too bad though. It's basically you take a look at your precedence chart and you create a rule for each level in your precedence chart. And the rule references the expressions below it with the lower precedence. And we'll see how that looks in a minute. And it's fairly easy to set up, a fairly easy idiom, but there's a couple little gotchas. Okay, questions so far? Yes?
Is the reason for the differences when you're using the language server protocol within Eclipse versus outside of it because of the client's usage of LSP or because Eclipse uses something different?
So the question is, is there a difference between using LSP inside Eclipse versus using the Eclipse plugins themselves? And yes, there's a big difference there. They do have LSP support in Eclipse, but again, it's still evolving. And they don't have access to quite as many APIs. So it's a fairly limited subset of what you can do to be an editor using a language server. Inside Eclipse, they have it set up to use all sorts of plugins, and their plugin framework uses Google Guava for dependency injection. So you basically define little modules inside of your IDE for things like highlighting, for things like scoping, for things like code generation, all those. And a lot of those things aren't available inside the LSP. So it's kind of a subset. So using the native Eclipse plugin support works a lot better there. And what you can actually do is you can take Eclipse and you can generate an application out of it that has all sorts of branding on it. So it'll still have kind of the general look of Eclipse, but you can do whatever branding on it you want. You can explicitly say which views and which plugins are provided. So maybe it's a more lightweight editor for a specific language. And then you can deliver that with something else. Now, I believe, I haven't tried doing this, you could create a plugin in IntelliJ to launch this Eclipse instance that has your stuff inside of it. So if you were actually inside IntelliJ doing your work and said, hey, I want to edit my model, it could launch that model editor for you. Not the prettiest thing in the world, but I believe that'll work pretty well. Okay, questions so far? Okay, let me create a new page and come out here. So, to make this all work, what we're going to do is start off with a copy of Eclipse. And I'm going to use Proton, which just came out. And inside Eclipse, we're going to drop in plugins for Xtext. Xtext depends on a few other things. EMF, the Eclipse modeling framework, not the band that sang Unbelievable a long time ago, if anybody still remembers that. And it also depends on something called Extend. Now, Extend is the guys who wrote it, Xtext, created their own Java++. It's kind of similar to Kotlin in a lot of ways, and it actually predated Kotlin. But there's slightly different syntax for how to do things. It has its own little language for doing templating. I showed you that a little bit in the first session for the code generation with little guillemots. And it also does some interesting things for dynamic dispatch at runtime, which you don't have in Kotlin, and I wish they did. It's not that hard to mimic in Kotlin, or in Java for that fact. It's basically you have a method that says I take an expression, and inside there I say, if the expression is of this type, then I call a method casting it to that type. And you can do something similar in Kotlin. It's even easier in Kotlin because of the way it does smart casting for you. So you could basically have a when statement that says, if it is this, call this other method, and it's done an autocast for you. So we'll see some of that a little bit later. But Extend is a fairly nice little language. It's set up so that they generate Java code for it behind the scenes. They've also set it up so that when you're developing your code generator, when you're developing your parser, you can set it up so that you can use parts of the Extend language, and they call that XBase, inside your language. So if you wanted to have Java-like expressions, you can just say bring in XBase, and boom, reference the expression rule. You can also reference Java types that way. And in your code generator, instead of having it be text that you use your code, you can use an API they have to reference the Java objects, have it automatically fill out the right imports for you, generate methods, generate classes, all that fun stuff via little declarative specifications. So there's some real nice benefits on doing that. The big drawback that I've had with it, a lot of the Xtext code that's generated works fine in Gradle. The Extend and XBase stuff is where it gets flaky. The plugins, the Gradle plugins, just don't handle it very well, and it's a lot of pathing issues trying to get set up. I'm going to try to set some of that up for next week. I don't know that I'm going to be able to get it to work because I've been wrestling with this one for a couple of years. Hopefully, I'll have my little breakthrough. I'll give myself a couple of days to have a breakthrough. That's always a nice way to start out, right? Worst case, I can say, "See, I told you it didn't work." But these are what I use for the code generator. The code generator is written in Extend, and you can actually use that to generate your Java code as well. Hopefully I can show you that. I'll at least be able to show it to you in Eclipse. I don't know if I'll be able to show you it working in IntelliJ though. So you take these Xtext plugins, drop them into your copy of Eclipse. Then you're going to write your DSL projects inside your Eclipse workspace. And the Eclipse workspace, if you're familiar with Eclipse, it's just a directory that contains all your projects. It doesn't have to contain all the projects. You can actually point to projects that are outside of it, but generally think of it as your desktop that you have all of your projects inside of. This is actually something I very, very much miss inside IntelliJ, because grading especially. I loved it when I could take all the students' projects and just suck them into the workspace at once and then just run them, as opposed to what I have to do now, which is click, file, open, find the next project, do that. Okay, now I'm done grading. I'm done grading. Now click, file, open. It's like, oh, I'm going to have carpal tunnel syndrome before I'm 52. So. Well, IntelliJ sucks up a good bit of memory too. So. Yeah, exactly. So once you have those projects, these are plugins. And the way you work with plugins in Eclipse, if you want to test them, is you start a nested copy of Eclipse as the application you're running inside your outer copy of Eclipse. And once you get used to plugin development in Eclipse, this is no big deal. It's kind of funky to start with because it really looks like I'm running Eclipse inside of itself. Why am I doing that? Just keep in mind the programs that you were developing in the base Eclipse are the plugins that you want to test. To test them, you need to put them inside Eclipse. So you run them inside this nested Eclipse. My normal development process at work for this one project I'm using this on is to have 2 copies of Eclipse running at all times. So I have the outer Eclipse with my plugins and then my nested Eclipse to actually process my model. So anytime I change my development copy, when I make changes to these guys here, sometimes I don't have to restart this nested Eclipse. So if it's just like code in the middle of a function, no big deal. If I add new methods or if I delete methods or rename things, I've got to restart that nested Eclipse. It's just the way that Hotspot works with Java. Yes?
Would that be for if you handed this out to someone else, they would have to try to learn the same thing?
No.
No?
And that's the thing. The only time you need to do this nested is while you're developing those plugins. Once you get to the point where those plugins are actually fairly solid and you want to release version 1 for somebody else to use, you take these guys, actually let me say export. You export them as a feature or just an individual plugin. A feature in Eclipse is a group of plugins that work together and it becomes a zip file. People can either take that zip file and install it into Eclipse, they can extract it into the plugins directory if they want to, or you can put it on an Eclipse update site. In the Eclipse update site, they can then use the Eclipse installer to point to that site, and then it'll suck the right stuff down and then find all the dependencies as well. The other thing that'll happen with it, you can associate that with the Eclipse Marketplace, which is basically where you can just search for things and then pick it. And we'll see that when we're looking for Xtext to install it. Yes?
What's the technical limitation that prevents Eclipse from running the plugins that you're developing at current?
So what's the technical limitation that prevents you from running the plugins inside the current Eclipse? Technically, you could. Note that I'm being very, very tentative in saying this because what happens is that means you destabilize your main development environment, and that's the main reason you don't want to try to do that. Eclipse under the covers uses OSGI, and what we could do is, as part of this build process here, have those plugins generate their zip files and then install them into the currently running OSGI instance, which works perfectly well. That's OSGI is supposed to do that. You can dynamically add and remove plugins. But the problem is if you do that, you're running a risk of destabilizing your core environment. And so it's really, really recommended strongly not to do. You also don't have the ability to debug. So it's like if you're trying to test this stuff out, there's nothing to attach a debugger to. So you think of this outer guy as your edit and debug environment, the inner one as the app that you're actually trying to debug. Now, OSGI, saying that, OSGI is great as far as being able to dynamically install and deinstall. Unfortunately, most plugin writers don't know how to do that properly because it's up to the plugin to play fairly and actually tell OSGI, there's some hooks you have to say, when I'm installed, let me start things up. It's especially bad if you're installing a new version. You have to make sure that you have things implemented in a way such that it will shut down your existing plugin and restart it with the appropriate parameters. So because of that, whenever you install a plugin in Eclipse, it will always say it'd be a good idea to restart Eclipse at this point, just because most plugin developers don't know how to do it right. And it's, I don't want to say they're lazy. It's just that there's a lot to learn when you're developing OSGI, and there's a lot of bad information out there. So a lot of times people will look at a sample and they will miss the good samples. They'll grab a bad sample and then not implement the stuff they need to implement. So moral of the story is if you install plugins in Eclipse, restart. Okay. Now, this inner Eclipse then, he is going to have projects that you create in a nested workspace. So it's a completely separate set of code that you're working on inside of there. So my development environment at work looks like out here, I have all of my plugins. Down here, I have my actual models and the code that I want to run the models against. Make sense? Okay. So fun little setup here. So what I should have done before I was talking about all this was go through the download and set up Eclipse process. So what I'm going to do over here is if you go to eclipse.org, that's where Eclipse lives, you can go to download. Now, there are a bunch of different packages you can download. I always like to go to the download packages link there. And inside there, they have a bunch of different packages, some of which you're going to say, what the hell are all these? Most of the time I like picking this first one because it has all the JEE tools set in there so I can do web apps. And part of my projects are usually a web application that uses the model for its data behind the scenes. If you want a more bare bones one, you can get the IDE for developers. If you want to know what the differences are, you can go up to this compare and combine packages. And this guy will tell you what's in each one of these distributions. So here's the EE one. You'll see that it doesn't have the C++ tools in there by default. So if you want C++, you can just add that in as another package. Let's see, anything interesting in here that... No, it has most of the stuff that's good. Note that it doesn't have extend and xtext by default. Xtext is only in the Java DSL version by default, but you'll notice there's a lot of stuff missing in there. So if all you want to do is just play with xtext and nothing else, you can grab that one. What I prefer to do is grab either the EE or the Java one and then add xtext into it. Okay, make sense? Okay, so what we're going to do is we're going to grab that Java EE version. And whoops. I'm going to come back out to here. I'm going to grab the Windows 64-bit. This should, if you're running Mac or Linux, it should give you a different screen here to say download different things. And this should be a zip file that comes down. It's not actually an installer. It's going to ask you which mirror you want to grab it from. I always go from OSU. That's, from all the times I've tried this, it tends to be really fast. I've already downloaded that, so I'm not going to run through that process. What I like to do is create a directory called Eclipse. You'll see that I have my Eclipse that I was working with before, the one that I was trying this cycle out earlier today, and now the one we're going to do right now. So here's that zip file. I'm just going to unzip it there. Fortunately, I'm not running on an APL machine, and it's not scanning every single file as it's extracting it, and so the zip is very fast. That generates this Eclipse directory inside here. Now in there, we have eclipse.exe. That's the guy you're going to run to actually open up Eclipse. What I'd like to do, though, is edit the eclipse.ini and change the maximum and starting heap size. So I'm going to make this guy be max heap size of 2 gig and starting heap size of 1 gig. And you can adjust that based on how much memory you have. For this type of stuff you're doing in this class, you're probably not going to need too much. It just depends on how many projects you're doing. So I'm going to save him. And now what I also like to do is take that icon and drag him down to my taskbar. There we go. Ta-da! And let's go ahead and run him. I like their logo for Photon. It's kind of neat. Okay, now the workspace that we're going to create, I also like to put that inside that parent Eclipse directory, just so I'm keeping all my Eclipse stuff together. So I'm going to come into here and go with Eclipse. Oops. Come on. Let's just make sure I type that okay. That looks good. And I'm going to use that as the default, and don't ask again when I restart Eclipse. Okay, so I'm going to kill the welcome screen. We're going to see that several times during this process. I generally like to go to the Java perspective. So I'm going to go there. How many people here are familiar with Eclipse? Get a little bit of iffiness. I'll go through a couple basics. I'm not going to hit a whole lot of detail, but this little chooser over here lets you choose a different perspective. And a perspective is a set of tools that are designed for a certain type of work, like Java work or Kotlin work or web work, things like that. That will adjust what you'll see on different menus at the top of the screen and when you right-click on things. So for example, if I'm in a Java perspective and I right-click on a package, and when I say new, it'll give me options for creating new Java class and Java interface, things like that. If I'm in a Kotlin perspective, it'll give me the Kotlin versions. Now, I tried the Kotlin perspective earlier today. It is fairly well behind and does not let you run code very easily. So I'm going to pass on that one. What we're going to be doing here is once I have my projects going, I'm going to import them into IntelliJ. So you can actually edit them in Eclipse and see the code inside IntelliJ for actually working with the code. Yeah, the process can be a bit hairy at times. Okay, so I'm going to kill my task list and my outline. So inside Eclipse, I'm going to go to my Help menu and go to Eclipse Marketplace. And then at the top here, I'm going to type in xtext and enter. And if I go down to the bottom, I'll see Eclipse xtext 2.11, and I'm going to hit install. Sometimes it takes a little while, sometimes not. This is where I should have gotten to this point and then gone and talked about the structure of things. Let's see, is there anything else I wanted to talk structure-wise? Yeah, let me go back over there again real quick. So, once we've got... Oh, I lost it. I wonder why I lost that. There we go. He's back. Okay, so once we've got these projects here, which are actual data, I'm going to import them into IDEA so that we can actually use them as a Gradle build inside there. Now, when I'm setting up these xtext projects, I can set them up using Gradle. It will actually create two builds, the Eclipse build and the Gradle build for it. Okay, let's see, was there anything else I wanted to say on that? Another alternative is you can set up your plugins to write to external directories. So you could keep your actual model source completely independent of the source that it's using, the generated source. I generally like to keep them in the same type of project tree, just so everything's consistent. That project tree will have my plugins, and it'll have the actual working code. And then the plugins get loaded into Eclipse. The working code contains the model definitions, as well as other modules that I need for my project. Okay, let me see here how this is doing. It looks like he came back. Okay, I'm going to accept the terms of the license agreement. And I can get him out of the way. And he's installing software. This usually doesn't take too long. And it's proving me wrong. Glad I didn't do this through my phone, though. That may have taken a little bit longer. I love how it jumps from 6% to 49%. I always struggle with progress bars in my apps too, because it's like there's sometimes you're like, you know, there's no handle in here for me to update it. So, you know, I'm downloading 3 files. It's going to be 33%, 66% done, you know.
I don't think there's any like established best way for all circumstances to do a progress bar, right? It just depends on.
And if there were, people wouldn't use them because they still want to be able to mock people for having 6% to 49%. It's all about the mocking factor. Okay, here's the, would you like to restart to apply the changes? Always say yes on that. You never know if the plugins are going to play well or not. So that should have installed xtext for us. Let's see, is there another one I needed? Oh, I tried installing the Kotlin plugin. We're not going to do that today. So now that I've got that set up, let's create our projects. So I'm going to come over here and say new project ... And go down to the bottom. I should see xtext and say I want an xtext project. Now, if you had already been working with EMF, you'd probably have some eCore models, which are meta models describing the data that you want to use as your models. So you could use that. We're just going to start with a brand new clean xtext project. And I'm going to name him com.javadude.states. I'm going to make the name of my language be com.javadude state DSL. The file extension is going to be states. Now, if you like to use working sets in Eclipse, you can check the box to do that here. Depending on how many projects you have in Eclipse, sometimes it's nice to have little folders. Those are working sets. I created a dynamic working set plugin a while ago for Eclipse where you can specify regular expressions and it automatically sorts your projects into different working sets. That was kind of fun. So here's how we're actually going to configure this project. I'm going to have Eclipse plugins. I'm not going to bother with the testing support. I'm just going to throw away the test project. Create feature and update site. Those are for packaging your plugins. I'm not going to bother with that because I'm not planning on delivering this. But normally you'd check those two boxes to create a feature that you could deliver to other Eclipse installations. Web integration lets you use the generated tools online in a web browser. So you can actually do editing on a web browser. I haven't found a good use case for that yet, but I assume if you wanted to have people be able to configure your server via DSL, you could do something like that. Now for preferred build system, I'm going to change that to Gradle. And here's the option now for building a language server. So I can say I want a regular or a fat jar. A fat jar contains all of the dependencies inside a single jar. So it just packages it all up for you using, there's a utility called Shadow Jar inside of Gradle. Regular is basically a jar and then a subdirectory of libraries that are dependencies, and you have to deliver that all together. So normally a fat jar is the way to go for LSP. I'm going to go ahead and have that generated in here in case we get to the point where I can actually try showing you the language server stuff. For source layout, you have the choice of Maven Gradle or plain. If you try choosing Maven Gradle, it won't work for the Eclipse plugin project. So you have to go with plain. The difference there is source main Java versus just source. In Eclipse, everything is just under the source directory. So I'm going to go ahead and hit finish. And you'll notice that this generates several projects for us. There's actually a top-level project called Parent. That's the top level of the Gradle project with these sub-projects for everything else. The main one you're going to work with is this first one. That's your base DSL project. And you'll notice here that it's put up our grammar to start with. If I expand him, I'm going to see there's only two things inside of here. The xtext file, which is what I'm editing here, and MWE, which is something workflow something. I can't remember what the name of that is for. But this is basically the build file for xtext. Okay, so now we have our little grammar here. Let me kind of take a look at what I wanted this to look like for our state machine. And let's just start off with, at the top level, instead of model, state machine. And inside there, I'm going to have state machine as a keyword. And let's see, what do we want to have this? Let's give him a name. ID is a built-in terminal that comes from this grammar that we're using. So we're pulling in terminals from there. And I'll say curly brace. And at the end of this state machine definition, there'll be a curly brace to match it. Then we're going to have some stuff inside of here. So if you remember way back to the first session when we had that Gothic security one, I'm going to do something very similar to that. We're going to have inside of here, let's say what our start state is. And something like that. I'm going to define a state rule here just for the moment, just so I have something to reference. Notice the brackets on this guy. This creates a cross-reference. So by default, this is going to look for a name field inside the state object that's created. That's what's going to appear inside my code assist. So if I'm at this point and I say start space control space, it's going to go through all the states that are visible in that scope, which for this example is going to be everything, and then print their names up. And then you're going to say start the name like that. when this is read in, it'll actually create links between the state machine object and the state object so that all the start state is actually pointed to. And it resolves that for you automatically. So down here, I'm going to want to say state name equals ID, curly brace, close curly. And now it's happy so far. Okay, questions so far? So now let's put in some commands. And these were those little 4-character sequences that were sent between the different devices in the home. So open a panel, close the door, turn the light on, things like that. So I'm going to say commands plus equal command star. Now the command star is probably familiar already. Let's define a command here. And he's going to have a name equals ID and a code equals ID as well. And you should say command in front of there. So when I reference a command, I'm going to have to type in the word command, followed by a name, followed by the word code, followed by the actual code I'm going to use there. This plus equals says commands is going to be a list, and every single one of these commands that actually gets used at that point is going to get added into that list. So once I have a state machine object, I can say give me its commands, walk through that list. We'll do the same type of thing for events. And I think it just has the same data in it. Yep, something like that. So far, so good. Let's define our states. And you could alternatively say, hey, maybe I require at least one state. That would probably make sense, right? Otherwise, you can't have a start state. It'd be impossible. So I'm going to put a plus there. Make sure you have at least one state there. And then reset events. You may have 0 or more of those. Let's define the reset. Something like that. And let's see, is that it for our top level? Oh, we had tests as well. We'll throw him down at the bottom. Something like that. Okay, so far so good. This making some sense so far? When this will allow us to parse pretty much that same grammar that we saw early on. It should end up being the same one once I'm finished. Once you have that, you can read it in, and it'll generate the model for you with a state machine object, command objects, event objects, reset objects, state objects, and test objects. Each of these have fields, like this guy has name, commands, events, states, reset events, start state, and tests. Make sense? Okay. Yes? How come we didn't need for referencing event and things like that? It depends on if you're going to link or actually own. So in this case, basically, this guy is owning these events. So I'm actually calling that event and putting it into a list for me. Later on, I'm referencing that event or referencing that state. Now, these references could be before the use. So like in the original version of this, I actually had the start state up at the top like that. It makes it a little harder to actually write the implementation of the DSL, because you have to start off by typing in start, and then if you try to do code assist, there's no state there to do anything with. So what I wanted to do this time is just move him down so that you have to define the states before you get to that point of the start, and then you'll have things defined. Okay. And similar for commands and events. Once you reference them, once you define them, you can use them inside the state. Okay, so let's see, we have command and event. So let's see, in states, we had some actions. So when we go into a certain state, what do? We unlock the panel or something like that. Let's call that actions. And an action is going to refer to an existing command. Like that. So we're defining an action, and the action is referring to an existing command. And then we need transitions. Zero or more of those. So we're defining a new transition object, and he's going to refer to some events and some states. So on event equals the referred to event, go to, oh, I said switch to. I should mention this right now while I'm thinking about it. Notice how I have switch and to as two separate tokens with quotes. I'm not putting switch space to inside of a single quoted phrase. Why am I doing that?
So the white space won't matter.
White space won't matter. If I had instead said switch space to, white space matters there. I have to have exactly one white space. I can't use a tab, can't use anything else. By making them separate tokens like that, I can now have as much white space or even new lines between them if I want to. Okay, and this actually, there was something in the assignment that's applied to, I can't remember what it was. There was one of the things had two tokens in a row. So you want to do the same kind of thing. Switch to target equals state. Kind of like that. And I think it's that's for that one there. And the only thing left is in the test to say what the events are that I want to send. So I'm going to say events plus equals reference an event. 0 or more. Actually, let's say 1 or more. Because it doesn't make a whole lot of sense to have a test without doing anything, right? Okay. And we should, the transitions, 0 or more is perfectly fine because it could be a terminal state. Let's see, everything else looks good. Yeah, we don't have to have any events for a state machine. It could be a rather stupid state machine with a single state and you never transition out of it. It could be no commands. Okay, I think everything looks good here. So this is our little grammar. Fairly similar to what we had in Antler. Not exactly the same. Keep in mind that these are actually generating classes whose fields are going to be filled in as it does the parse. Make sense? So now we're going to generate this guy. I'm going to go to the MWE2 file, right click, and say run as MWE2 workflow. And it's going to run this guy. Hopefully I got everything right. If you get down to this point where it says done and you see it says terminated, you know everything's fine. Make sure you wait for the build to complete. Sometimes it'll say over here on the side that it's still building. You'll notice that it generated a lot of extra code in here now. So now we have these two modules which are written in extend. We have a generator class, we have a scope provider class, and a validator class. We're going to use the validator class a little bit later. But right now, they just generate a little stub with some commented out sample code saying, hey, here's something you might want to do. Okay, so now that we've generated that, it's also generated code in the IDE and the UE classes, UE packages. So at this point, I can go ahead and run that nested Eclipse, and I will have an editor with syntax highlighting, content assist, and model generation capabilities. To run it, I'm just going to right-click on any one of these projects and say Run as Eclipse Application. So this is where I'm running that nested Eclipse. And I've already got a configuration there, so I'm just going to choose one of those. I don't know why there's two of them. And if you're really doing plugin development in Eclipse, you can mix and match and choose which plugins you want to use in that nested copy. By default, it uses everything that was used to run the outer copy, plus everything in your workspace. So here's my nested one. I'm going to switch over to a Java perspective. I'm going to close this other one. Yep.
Is there any way to make it take your preferences and stuff like that?
Is there any way to make it take the preferences? There is a tool, what do they call it? Oomph? I think it's called Oomph. And what it does is it basically writes your data, writes your preferences to a server and then reads them back. So you can use that across all your Eclipse installations. And I think that'll work. I think by default, I'm not sure if it copies your settings from the outer workspace by default when it first creates the inner one. I think it does, but I'm not sure about that. Okay, so now I'm inside this nested Eclipse. I'm going to say new Java project. And you could just do a new normal project. So if you didn't want to actually have any Java code inside here, you could just say new plain project. And I'm going to say sample 1. Actually, let's say test 1. Why not? And I'm not going to need to change the class path yet. And hit finish. And then inside here, I have my source directory. I could create a package if I want to, or I could just drop a file directly in there. I'm going to say drop a file in there. And I'm going to say Gothic security .states and hit finish. Now, if you type the right extension, it should prompt you to make this an Xtext project because it'll recognize, hey, there's a plugin in the system that handles that extension. Do you want to use it? And so in this case, it's asking, do you want to convert it to an Xtext project? Now, convert is a weird word here. What it really is doing is adding the Xtext nature to a project. In Eclipse, each of the projects has natures associated with them. So if we took a look at, go to the filters and not filter out the .star resources. If I took a look at my my .project file here, we'll see in here that he has some natures defined here, a Java nature and an Xtext nature. Eclipse uses these to determine how to build a project and what tools are available to a project. The build spec here gives the chain of builders that will be executed in the order they'll be executed whenever you touch something inside that project. So we'll see that it added the Xtext nature and an Xtext builder up at the top here. Now, right now, we're not doing any code generation, so the build doesn't really do anything. It's just going to validate if a validator exists. So this Gothic security.states file is empty. I had a default version of him. I'm going to have to tweak a couple little things. Okay, why are you not? Hello. That was weird. It wouldn't shift to that window. Okay, and boom. Now we'll see we have some syntax highlighting in here. It's complaining that start is not there because it's saying that required loop doesn't match anything at input start. I'm going to move him down to the bottom. I think it was just before the tests, right? Maybe it was before the reset. Oh, actually, I called it something else. I didn't say reset on. Reset event. There we go. And let me see where that test was. Maybe I put it in the wrong spot. It comes before the start. Okay. Not really where I meant for it to be. I'm going to fix that. So because I'm going to be changing the grammar, I'm going to close this nested Eclipse. I'm going to move the start before the tests. Anytime you change the grammar, it does not automatically get compiled in Eclipse because it takes a little while. So they decided you have to do this as a manual step. So you got to rerun that MWE2. So run as MWE2 workflow. And now I'm going to run that nested eclipse. Note that I'm running it in debug mode here. That allows me to do some changes on the outside and have it be effective without having to start that nested eclipse. That's really nice when you're doing code generation, because a lot of times you're just going to be tweaking what's inside your template, and that doesn't affect anything that Hotspot cares about. It'll just reload that method. Okay, there we go. That's better there. So what's happening here? Couldn't resolve reference to command action. Oh, I didn't have the word action in there, did I? Yep. So what it was trying to do is trying to treat an action just as a reference to the command word directly without having that keyword action in front of it. That's what I told it to do, and it was obliging. So let me run that again. Oops. Okay, and then we can run our nested eclipse. I did that time. Now you don't have to. You could actually, inside this, the outer eclipse, you could just hit the stop button here, and it'll just kill that process completely. Depends on if you care about cleanup or not. Okay, there we go. So now everything's nice and clean there. Now if I came in here and I wanted to say, what can I do there? I can hit Control Space, and it gives me command, event, or state, or possible things at that point in the grammar. Command and event are optional. State is the next thing after it. Once I'm inside here, like if I said, let's say for state foo, maybe I want to add an action, I can let the content assist give me, here's your options for the actions you can run. These are the valid commands. And as I start typing, it narrows them down just like any code assist would. So I'll say lock the door, and then I can say on, it'll give me the events. On light on, switch to active. I don't know, something like that. Just kind of a random thing there. So it gives me a nice little content assist there. It gives me error messages to say what's valid or invalid about this. And so now I know if somebody edited this through this editor, the syntax should be valid. The links should be valid. Now always keep in mind that somebody could edit this file outside of the editor, just a normal text editor. So you can't assume that the validations are going to hold when you actually go and load it. So when you load it separately, you're going to want to rerun the validations against it. And the parsing will actually give you error messages to say, hey, the user screwed something up. But what's nice about this editor here is that it gives you the same type of support you get in pretty much any type of language there. And if I wanted to, I could change the coloring on these different features. I could set up, let's see what happens if I try formatting it. I don't think this is going to go well. Yeah. Because I didn't define a formatter, so there's no default. But with a formatter, you can say how things are nested and how they should be treated with new lines and spaces and tabs and things. And then that actually will show up as well on, if I go to Properties, it doesn't show up there. It's in the, oh, actually, I think that was that it? Oh, it's just Run Debug Settings. So if I go to Window Preferences, there's oomph, State DSL. Then under here, I have where the output directory is and all that stuff, what I want to do for warnings. So if you set up specific warning, different types of warnings for different things, you can have them show up in here. Refactoring, if you define refactorings, that's another thing you can add in. Syntax coloring. You can do, these are the default versions of syntax coloring. You can override those. You can have different sets of things. And then templates, if you want to actually define some templates for the user to work with. So I could say, here's a state template. Might look like state. Oh God, it's been forever since I've done this. I'm going to type in something hacky just to show you how the templates work, but I could say on $name, go switch to $name. And then inside here, I could type state. And that's not working there? Huh. Did I miss? Oh, I put it inside context action. Yeah, that's the problem. So this one should be inside of a state machine is where it's okay. And so now I can type in state. Hey, come on. Huh. That should be working. About ready to abandon this. That is really weird. Let me call it something else. Maybe there's something that it doesn't like in the conflict with the keywords. No, it's not letting me do it. That's really weird. Sorry? Shouldn't have to. Because what it should do, let me show you what it does normally in Java. So if I had a new Java class here, sample, and let's say I want to define a new template, I could say something like string $name equals quote $name. Come on. And what did I call that? D1. There we go. And so now when I change one of them, it changes the other one too. Ooh. Linked template editing. Cool stuff. That should have worked, but then again, I've never tried it in Xtext. So I was assuming it would work, but it doesn't really hurt anything what we're doing here today. Okay, questions so far? Yes?
So if you were within that foo function and you like went to definition on Python, would it actually, you get like IDs?
Yeah, so if right now I can control click on it and it'll jump up to where it's defined. You know, this guy will jump to his definition as well, down here. And does it give you the type? Yeah, so it gives you the type of it when you float over it as well. So like event light on and state active, command unlock door, things like that.
Is there a way to make it fill out like the documentation?
Yeah, well, yeah, there actually is. There's ways to set up hovers. It doesn't come up by default. Oh, actually, it does. So there's not a whole lot there. I don't have it set up to do any type of dot comments on these. And that, I don't believe, will do anything by default. I could be wrong. Let's see. So that's for door closed. Ooh, sweet, it worked. So yeah, you could put in documentation comments. I didn't realize you got that for free. I thought you had to explicitly put comments in there. That's nice. Okay, so questions? So this is now set it up so that there's an editor for this code here, and I can use that to load in whatever I want to read. So let's set up a little loader for it. Let's see, do I want to do this in Kotlin or do I want to do it in Java? I want to do this in Kotlin because it's just so much nicer in Kotlin. Kotlin's just a nice language. I love Kotlin. What can I say? So what I'm going to do is I'm going to take this test project here and I'm going to import it. But in order for that to work, I'm going to need to have it underneath the other project so I can reference it. So let's put this section on pause for a second. I'm going to shift over to IDEA and import the Gradle project. Then add a module and copy this stuff over. So this is if I were doing things in Eclipse, I could come in here and set up some Java code. And inside here, load up the data, do something with it. It's a lot more verbose here. I'm going to do it over in IDEA. And I don't have IDEA running, do I? Hello? Let's start him up. Yeah, that's what I wanted. Okay, so what I'm going to do here is go to Import Project. And I'm going to choose where it is. Let's see, where did I put that? So it's going to be underneath Eclipse, Eclipse Workspace, and then that top level parent. So you'll see here, that's the top level parent Gradle project, and the other IDE stuff is underneath it. So I'm going to say OK. I'm going to import it as Gradle. I'm going to use auto import and say create directories for empty content roots if needed. Anything else I need to change? Nope. And this is going to set it up to be used as an IDEA project. Okay, so now we have our parent project. Underneath it, it has the other IDE projects. I can go to my terminal and say Gradle W build. And we'll see that it's saying generate xtext language is one of the steps. That's what that MWE was doing. So you'll see the same kind of output up here. Now it's compiling our Java code, setting up our distribution, creating a shadow jar. The shadow jar is the thing that we could use for the language server. And so far, so good. So what I'm going to do inside of here is create a new module with Kotlin. I'm going to call him test1. And I'm going to regret that because I didn't, I knew it was going to do that. It didn't create those subdirectories. That checkbox only creates the subdirectories on the way in. So I actually need to come out and say, go to File Settings. Was that right? Build Tools, Gradle. Create directories for empty content roots automatically. That should have worked. How did I get that to do it before? Let me try that one more time. New module. Now, is there an option that I missed somewhere in here? No, I don't see one. Watch it work this time. Just to spite me. Of course. Thank you, IntelliJ, for being so consistent. This is what it should have done to start with, is created these subdirectories here. So source Kotlin, source test, things like that. So I now have my source Kotlin directory. In the build.gradle for that test, I'm going to need to depend on the model definitions that were generated by xtext. Those are up in that com.javadude state project. So I'm going to add a dependency for those. Now, for those of you who've done the Android class, you remember that we had implementation versus API as the options for dependencies. Those don't exist outside of the Android stuff, so you're just going to type in compile. So I'm going to say compile project com.javadude.states. So that will reference the generated code for the models. Okay, I have this set to auto import, so it's already imported that. Oh, it should just be state. Thank you.
Sure.
Yeah, because up here it just says com.javadude state. I probably wasn't. That's the wrong one. It's this one here. I'm surprised that it didn't bark at me there. Okay. Sorry? Oh, what's the colon? The colon is for a sub-project. So in Gradle, your top-level project doesn't have the colon. Every time you go down a level, If you have like nested directories, there's a colon in front of it just to say that that's a sub-project. And then that also, when I created the module, it's listed as an include inside the settings.gradle. So that'll be my these are my sub-projects from the top level. Okay, so now I've got him set up as a dependency. I should be able to, inside of this, let's go ahead and create a little Kotlin file. Let's call it test1, make him a class. Companion object, public static void main. And inside here, I could say state machine. Boom, and you'll see that that comes from that state DSL. So I'm actually referring to that state machine in the state DSL. Now, I'm actually regretting the names that I chose here because we're going to have names that are associated with the DSL and names that are actually associated with the state machine objects we're going to create. So think of those as two different things,
We have
two different packages. So it's going to be a little bit of a crossover there. So the first thing I want to do is bring in my definitions of the actual data. So let's go to here, and that all looks good. I think I already had test1 defined in there. Yes, I did. And I don't have a package on this. Let me create a package for him. New package, test1. And we'll take this guy and go, whoop, drag him in there. It's only a matter of minutes until I get annoyed at the dragging there and turn it off. Whoops. What did I do? Oh, no.
Look, you're already invited.
Yeah, I did the wrong thing there. Oh, come on. Seriously? Where did it go?
What does it say this code is now? Common Java good state parent.
So test1, source main Kotlin, test1. What is it showing me here? It looks like it's collapsing things somehow here. Oh, let's try it under here. What? Oh, so that's actually okay. So where'd that package? I guess I undid the package. So it was probably okay, and I just thought it wasn't okay because it was showing me things weird. Okay, so let me drag him into there. Okay, that's right. That's weird. Okay, so anything else in here that it doesn't like? That all looks good so far. So
You got another states with an S.
You go to your scroll bar, then there's a red bar towards the right on
The other one for the file.
that is this guy.
the right. And
Oh, I see what you're saying. Gotcha. One more. There we go. Okay, so now let's talk about what's inside this file. So I did a couple tweaks to the original model that I showed you the first day of class. Command and event just have name and code. I had a common superclass form before, which really didn't bias anything. It's actually cleaner this way. State has a name coming in. It didn't before. And then I set up the actions and transitions to be late init variables. This tells the Kotlin compiler, hey, I promise you, I'm going to assign these before I use them, which means I don't have to do null dereferences all over the place. But it still will check to say, did you keep that promise? Okay. So I'm going to be assembling him and then using him later. Okay. The state machine class, I have reset events. That's a late init. I'm going to point him later. And then this reset target method is just going to check to see, is the event a reset target or not? If so, return the start state. Otherwise, say, nope, not going to return anything. So I'm just doing my normal transitions. Command channel was just this little helper to say how I'm sending the commands to different devices in the house. So this is just a really simple one that just dumps the thing, but a real version of this would do something to talk to the bus that's actually connecting all these devices in the house. The controller is going to keep track of the current state. Before he had it passed in, I'm not sure why I did that to start with, but I'm going to have the current state be the state machine, and then my handle is just going to dump out what event was passed in, try to figure out the next state, and then based on the next state, I'm going to say if there is a next state, change to it, and run any actions that might be defined for that state. The tester here is where things get interesting. This is where I have to load up that DSL, and I'm going to have to actually define all instances of all those objects based on what was coming in. So let's take a look at him to start with. The first thing we're going to do here is create an injector. We do this by calling state DSL standalone setup. This is generated for us by Xtext, and call create injector and do EMF registration. So this tells the EMF platform, which by the way is actually getting included as a dependency here, what our model is, and registers it with a certain URL to reference that module. And it says anytime you see a states file, the appropriate model to use is the one that I registered in this create injector and do EMF registration. This creates a Google Juice injector. They're using the Juice dependency injection framework here. I can then use that injector to get instances of a resource set, which is an EMF entity to say, here's some resources that I'm going to play with, just as a group together. I'm going to get a reference to a resource, which is, I'm just going to create a URI. Note that this URI is an EMF URI. It's not a java.net URI, or not an Android URI if we were using Android. So I'm going to create a reference to test1 sample states. So I have this test1 project underneath my parent, and I'm going to create a sample states right at that top level. Let's go ahead and copy him over. Where did I have him? I had him in this nested guy, test1, source. I'm going to have to rename him. Okay, note that I'm not getting any type of syntax highlighting here. Gothic security .states. Okay, so this is a reference to my resource. I'm going to actually do a load of that, passing in no options. So at this point, it's loaded that resource into the resource set. I can now take that resource and start working with the contents that were loaded. So every resource is going to have a list of things that were loaded into it. That's this contents. Now we know there's only one root here. In any type of Xtext project, there's only going to be one root for it. So I'm going to get context 0, and I'm going to say he's a state machine from that state DSL definition. So that's our top level guy here, was this state machine. He was generated based on that rule being triggered. There we go. Now we get to actually create our objects and load things up. So I've got the state machine def loaded. Let's go ahead and get all our commands. So I'm going to say val commands equals. I'm going to take that state machine def, and I'm going to take a look at the commands inside of him and map them by saying I want to create a map for the commands so I can look them up. So the key is going to be it.name, so the DSL command's name, and the value is going to be a new command object, and this is going to be the command that's defined inside this file. I really should have picked different names or had a prefix or something in the DSL. It.name and it.code. There we go. So I'm just reading the data out of that object that was used to parse things in and assign it somewhere. Boom. And I want to say, create a map out of that. So what this did when I said this map here is it's creating a list of pairs. The first item in the pair is the name. The second item is this command object. By calling toMap, he takes a list of pairs and creates a map out of it. So now it's a map of strings to command objects. I can do something similar for events. Just like that. He was nice and simple. And now let's create our states. So val states equals state machine def dot states dot map. And we're going to do something very similar here. It dot name to state of it dot name, like that. And again, create a map out of it. So if you remember from that first class, I had several examples where we were, first of all, reading the data in and creating some maps so that we can reference them. Then we end up referencing them later to do the linking. Okay, to fill in the transitions, state machine def dot states for each. I'm just going to walk through them. And did I want to use a variable on that? No, I think I'm okay there. So I'm going to say states sub it dot name. So I'm going to look up the state that I created earlier. Dot actions equals. Now, because I know here that I walked through all these states and created state objects, down here I know that's going to exist. So I'm going to say bang bang. Now I want to take the actions defined in the DSL and create references to them inside the actual object I'm going to use to do the running. So I'll say it.actions .map. And what do I want to have these guys do in here? Commands sub it.name. So I'm just going to look the guy up. This is a different it here. Just to make that a little bit more clear, I'm going to do this. I'm going to say action arrow action.name. So what this will do is it'll say for each action in the DSL, take that action object, get its name. Actually, not name, it was command, right? Yeah, get its command, and then look it up in the commands object. Now this is nice and red here. What he's telling me is that he requires a list of non-null commands, but I have a list where the commands could possibly be null. The reason for that is that when I do this lookup in the map, it could return a null. So what I'm going to do here is instead of saying map, I'm going to change this to say map not null. And what that does is says anything that returns a null, just ignore it. Don't include it in my result there. Okay. And
Action is null.
any action, well, the actual thing that I'm creating here. So the thing on the right-hand side. So this, when I look up this command, if it's not found, it's going to return a null, and therefore I'm just going to not ignore it
So
when I'm
action
creating.
could be null as long as, well, no, I guess it could get a null pointer, but
Right. Okay, so what is he complaining here now? Type inference failed. Oh. Okay. In the action, I had a reference to its command. That was that command equals bracket command. And so once I have that command, I'm going to get the name for it and then look him up. So this is going to map the DSL actions into actions that I can use here locally. Now, if I change the way my data worked locally, I probably could just directly use that DSL set of objects, which is already linked. I just didn't want to change it at this point. Okay. Now, we're also going to do something similar for the transitions. It's a little bit trickier, though. Is this doing what I thought it was doing? Yeah, so inside here, I'm going to say I want to go from event to state. So it's going to be events sub transition dot event dot name to commands, actually states transition dot target dot name. Now he's complaining that what I'm creating here is a list of pairs which could be null to null for a given pair. And I want all those pairs to end up being a non-null to a non-null. That's what he's unhappy about here. So if you take a look in the little microscopic box that's popped up there, he says he expects a list. If he found a list of pair, event question, state question. But he actually wants a map of event state. So two things. One, I've got to fix the nulling. Two, I've got to convert it to a map. So here's the convert to a map part. We can just do that. So I'll say to map.
That's not the bracket you want.
Oh. There he is. Dot to map. Okay, now he's saying at this point, this is a little bit more clear now. Map event state is not the same as map event question mark, state question mark. So a couple things I can do here. I got to take a look and say, is it really possible for this to be null? To come back a null. So transition event name, is that event name possibly not in my events? And this is where you got to think about the user editing outside the editor. Because the user could have typed in some gibberish there. So we have to take a look at this and say, you know, it's possible. The user could have screwed this up. If I put some validation up here first, I can guard against that and then assume that we're okay. So that's one option. The other option is to actually say, if it's garbage, throw an exception here. So if I want to take the if it's garbage approach, I can come in here and say, take this guy. I'm going to say question mark dot let and say event up here for it. And what this does for me is says evaluate this guy. I wanted to indent that. There we go. Evaluate this. Try looking him up. If he's not null, go inside this lambda. If he is null, I'm not going to do anything. I'm just going to have it, the value of me is going to be null. I can make a otherwise by using Elvis and say throw new illegal argument exception because some people are picky about that, but no new. And there he is. Event dollar event dot name. Whoops. Transition dot event dot name not defined. Something like that. And then I can do the same kind of thing for the other part of this. Boom. For the state. So this is one approach you could take to the validation. There we go. And if both of those are true, then I'm inside here and I can just say event to state. Boom. And everything's nice and happy now. Does that make some sense? I know I'm blasting you with some syntax here, but this type of idiom in Kotlin is pretty common, where you can use the null check with a let to assign a value. At this point now we know that even if whatever was driving this is some properties that might change in other threads, we've already evaluated it once and we've got a lock on it. So it can't change again in the body of that. And then I have the, if it's null, throw some kind of error.
Not a lock. You have a reference to the
I have a reference to the value at that point in time. Yeah. So I've locked down that value at that point in time, so I don't have to worry about it changing. It can still change.
Could then point to something else, but you don't.
Exactly.
You won't see that.
Exactly. Yeah, the value of this expression could change while I'm inside here. Doesn't matter because I've now grabbed a hold of its value at a specific point in time. This is very different than saying if events transition event name is not equal to null, and then inside it say using events transition event name because that transition event name could have changed, or the map could have changed in the meantime. Okay, so does that make some sense what I'm doing here? So we're creating that pair, converting it to a map. That's going to be our state transitions. Okay, I think, is that all I had to do there? And then I just create my state machine. So now I can say val state machine equals state machine, and this is my local state machine that I'm creating an instance of. I'm going to pass in state machine def dot name. Oh, wait a second. Oh, it's a start state I want there. So I'm going to have to look him up in my states. Legal argument exception. It's left as an exercise for the interested reader. Yep. Oh, inside there, yes. Because it's the actual state that I want. There we go. So I'm going to look up that start state. If I don't find it, I'm going to throw that illegal argument exception with appropriate guts inside of it, and then create the state machine. Okay. So finally, after all that, I can start running the tests. So we can say state machine definition dot tests for each, and inside there, let's go ahead and just call this test over here. I'm going to create an instance of, what was the name of that thing? Controller. And I need to pass in my state machine and a new instance of, what did I call that thing? Command channel. And then we can just walk through all the events that are happening. So say test.events for each. And let's go ahead and just say event in there. And we'll say c.handle events sub lookup event dot name blup blup throw legal argument exception. Something like that. And so that should be able to run our tests, ideally. Hopefully I typed everything in right here. I want to put a couple little prints in there just to say what we're actually running here. So println running test, test.name. Let's put a separator in there. And was there anything else I want to do in this one? No, I think that does it. Okay. Cross your fingers. Let's see what happens. I could run it as a Gradle build, but I actually could just run it internal as well. So uninitialized property access. So I didn't handle reset events. I didn't set those ones up yet. So this is what happens if you make that promise and lie. So let's fix up our reset events there. So we will say that's setting up all of each of our states. I've created my state machine. I can say state machine. What the? That was a saturated something or other. So reset events equals state machine definition, reset events, map, and so we'll say You have to look up it.name under events. And I'm going to say map not null and just ignore things that aren't defined. Not a good way to go about it. We really should throw exceptions on that. That looks him up. I need a set. There we go.
Which will just throw away duplicates.
It.event.name. Yeah. So if there's any duplicates, we don't care about them. We're just using it as a set lookup. Okay, now this time for sure. Ooh, nice. Okay, so there we go. So this should look kind of similar to what we had that first class, where we're saying they closed the door, I'm changing my state to idle, opened a drawer, change the state to active, turn the light on, changing it to waiting for light. Am I printing the wrong state? I think I'm printing the wrong state there. I think I'm printing the state before it got changed. Yep. Not good. Let's do that. That would make a little bit more sense to do it this way. That's better. So we start off in the idle state, switch to active, switch to waiting for light. In light on, we change it to unlocked panel, perform our actions to lock the door and unlock the little secret panel. Woo! And then the other ones work very similar. This is one that was saying, oh, I opened the door too soon, so I'm doing that reset event to kick us back out there. Okay, questions on that? Yay, it worked. So this is a way that you can use data, just pulling the data in. And I probably could have rewritten this, now that I'm thinking of it, so that we could directly use those data objects that were generated instead of basically copying them over here again. That would have been a little cleaner. Maybe I can do that during the break. We'll see. Okay, so questions on this? So I'm using this just as a data carrier at this point. I'm not generating any code. That'll be next week. And the grammar for it was fairly simple. So if we take a look at the grammar on this, there's nothing that's recursive inside this grammar. Everything is very structured. State machine contains events and states and commands. States contain transitions, things like that. So no recursive definitions. You're going to have recursive definitions. Yeah.
You said we can't really do recursive definitions, right?
Oh, you can, but the trick is the left recursion you have to factor out. So it's a refactoring issue. And that's what we're going to see after the break. How's that for a segue? Okay, let's say 6:20 we'll start back up again. Okay, so the first thing I want to talk about is July 31st, which is a Tuesday. I've been asked to host an escape room for a summer camp, and that won't be done until about 3:30, and it's in Westminster. So getting here at 4:30 is kind of unlikely. So would you guys be willing to start later that day, or possibly switch to a different day? What would make more sense for you guys? I mean, I'm thinking if we started at 6, would that be okay? I mean, I could cut this class a little shorter too. It wouldn't be 7:30, but maybe 6 to 8, 8:15. How's that sound?
It's not till 10, I think.
Okay, we'll make it 9:45 then. Yeah. Let's say 6 to 8:15, 8:30, something like that. Does that sound okay? Okay. I will double check. I don't think there's anybody after this class. I'm pretty sure there's nobody else has a room, but I'll just double check that that's okay for the room. Actually, let me go do that right. And we're back. But thank you, everybody. I appreciate that. And so will the kids we're doing this camp for. It's going to be a Harry Potter escape room. Woo! So it's like I'm trying to scramble to put things together for it, and hopefully I'll do an okay job. And
Come to the escape room and then come to class. Is that extra?
that would be credit. Wouldn't be extra credit. But I'm hoping it's going to turn out okay. I mean, they're not giving me a whole lot of details on what the room looks like, so I'm kind of like blind on, can I rely on black light for anything? Does the room get dark enough? and what's the shape of the room, because I was thinking of taking an Android tablet and then creating a little Marauder map on it. So you could say to it, I hereby swear, whatever that phrase is, and then mischief manage to turn it off. Fun little things like that. Okay, so during the break, for the first couple minutes, I went ahead and said, let me try this without all those extra objects. So I created another test, test 2, in package test 1, because I just didn't want to bother creating another directory. I renamed command channel to command channel 2. Ooh, exciting. I renamed controller to controller 2. And the differences that I did inside here is in the controller, I created a method called getNextState instead of having that check where I was just getting the state directly and then calling that reset events guy, because I no longer have methods inside my state machine. So I basically had to put the logic for figuring out the next state in another method, another function here. So in this function, what I'm doing is I'm saying, let me take a look at the state that's passed in, and this is the DSL state now. Get his transitions and walk through them. It's not a map, so I can't do the direct lookup like I used to be able to. So it's a little bit of a performance hit on this because of that, so I'm going to have to walk through it. Chances are there's going to be a very few amount of transitions anyway, so it's probably pretty negligible. So if the event is the event being passed in, and I know that because they're linked objects, right? Then I can just return the target of the event. If I get past all that, saying I didn't find a transition that matches, then I'm going to take a look at the reset events in the state machine. And if the event for that reset event is the event, return the start state. Boom. With that change, everything else was just a matter of changing the names of things to using the DSL guy, and it works. That was a lot less work now, wasn't it? I'm glad I went through the first example, though, because a lot of times what you have for your DSL, your semantic model, doesn't necessarily match what you actually want to use at execution time. So if you were really concerned about performance and things like the being able to do that map lookup, you'd want to at least do some of that mapping that we did. Maybe throw it in a different object or something like that. Make sense? So that's nice, and that was quite a bit simpler than I thought it was going to be. So now let's go back over to Eclipse. Let me go to my nested workspace. I'm going to close the nested guy. Go to my outer Eclipse. And let's create an expressions example. So new project, xtext project, com.javadude.expressions. Come down to here, and we'll say expressions DSL. Where was that? There we go. And next, skip my testing. I'm going to use Gradle with the language server, the plain layout. I think that all looks good. And now we're back to another little grammar that doesn't do anything. So for this expressions DSL, I'm going to start off at the top level. We're going to have we're just going to use the word model to represent the entire contents of the file. I could call it program or something else. I'm just going to call it model. Why not? Put my colon in the right spot. That sounds medical. I don't know why. And then we're going to say expressions plus equals. Actually, let's call it statements. Something like that. And a statement can either be an assignment or whatever my topmost expression can be. Now let's think about the precedence in this grammar. These expressions, we have the plus, minus, times, and divide, right? Our highest priority, we also have parentheses. Our highest priority is going to be parenthesized stuff or terminals. So things like literals or variable names. Those are all my high priorities. Next highest priority is going to be times and divide. Next highest priority, and actually the bottom of it, is going to be the plus and minus. So we're going to start by defining the plus and minus rule. I'm going to call that an addition. And let's say that we can have, let's see, addition. What you do with the addition is you start off with a call to the next precedence level higher. So it's going to be a multiplication. And then you optionally have 0 or more plus minus something, plus minus something, plus minus something, plus minus something. Because we're doing this as right associative. So I could say inside here, plus or minus, followed by another multiplication. And by the way, if you don't have something defined yet, you can actually hit Alt/, and it will do a word lookup. So because I'd already spelled the word multiplication before, it sees that and just replaces it. 0 or more of those guys. So an addition is go to that lower level, any lower level thing plus or minus the next lower level thing. A multiplication is going to be a primary thing times or divide another primary thing. And again, right associative. You can just keep appending more of those on there if you want to. A primary thing is going to be either a variable or a literal or paren addition paren. And now we have a variable is going to be name equals ID. And a literal is going to be value equals int. Something kind of like that. Now, lots of red showing up in here. Oh, I didn't do assignment yet. So assignment is going to be variable equals, we're referring to a variable that we've defined somewhere else. Actually, no, we're defining the variable here. Ew. See if this will cause a problem if I want to change his value. So what I really need to do is have a statement possibly be a variable definition.
I don't know. I was just saying you could just call it
Declaration is fine. Yeah. Oh, I see what you're saying. Yeah, we can. I'm just gonna say screw it. Variable declaration is good enough. Variable declaration. You know, I'm just going to call it a variable. Why am I calling it something else? So it's going to be var name equals ID. And get rid of this one down here. This will be a variable reference. Which is going to be variable equals variable. Now the reason that I didn't just put the bracket variable here is because of the way that Xtext does type hierarchies. Anytime you have a rule that just references other rules, primary is now a superclass of variable ref, literal, and addition. That way you can use any of these guys anywhere you could use a primary. So it also gives you some class hierarchy definitions. Sometimes that's a pain in the butt. And it's actually going to be a problem here with the addition and multiplication guys. Because what am I returning here? It's like I'm expecting to return an addition guy, but no, I'm returning a multiplication guy. That's not going to work. We'll come back to that in a second. So we have our variable reference is an object that is a subtype of primary. Our variable declaration, I'm just going to call him variable, is going to create the instances of that variable, and then we're going to reference them later on. Now, with the way this thing is set up, it actually would be legitimate to define the variables after you use them. Because the referencing and linking can happen in any order. Now we could be explicit about that and say that, first of all, I have variables, and then I have statements, and go like that. And now I'm requiring you to define variables, or declare variables, before you actually use them. Make sense? Okay. So now these guys here.
You need a star, or you're stuck.
Ooh, yeah. Well, we only allow one. You can only have one in your grammar.
Variable in assignment is this one. It's a variable. It's a variable.
Where did I have that? Oh, variable. Okay. And I didn't finish it either. Equals addition. And this is going to be value. So now these guys here. Anytime that we're creating a rule here, this is defining a type. And when you come into the rule, it's going to create an instance of that type the first time you mention a field. So at this point of variable equals, it creates an instance of assignment, then assigns the variable, then assigns the value. Now, if I didn't have that value there, you notice that it had the underlined red there. That's because I'm now saying I want to have a different type of object coming out of this. Unassigned rule call is not allowed while current was already created. As soon as you reference a field, it creates a variable it calls current to hold on to all those fields. So current is of type assignment. The first time it sees, or if it sees any other types, it's going to assume that this is going to be a subtype relationship. So just addition by itself is saying I want to be a subtype of assignment, but I already created an assignment instance, so I can't have a subtype relationship anymore. That's why I had to type value equals, so he actually becomes a field in the current object. Down here, it starts off saying I'm creating this subtype relationship. Multiplication is a subtype of addition. Primary is a subtype of multiplication. Addition is a subtype of primary. Uh-oh. You now have a recursive definition here. And if we take a look at what it's complaining about here, that's what it's going to say. A class may not be a supertype of itself. It's a little bit indirect here, but if you follow that through, you're going to see that, nope, now we've got a cyclical reference in my hierarchy. I can't do that. So what we need to do is create a common type for addition, multiplication, and primary. I don't want to have a reference to it somewhere because I'm not going to need to say, oh, it can either be an addition, multiplication, or primary someplace. I always want to refer to addition as the top level thing. So what I'm going to do is create a new type called expression and just have all these rules say I return an expression. And I do this by saying returns expression. Kind of like that. That changes the type of the rule. So instead of the rule explicitly being the type that it's named, he now creates a new supertype for them called expression. Does that make sense? And the rule may return an addition. It might return some other type of expression. But now because of that, I'm okay in my recursion issue there. But I have some other issues here now. I start off saying, okay, I come down here, I'm creating a multiplication type. So that's the type of the thing that's going to be returned. Uh-oh, I might have something else. What do I do with this other multiplication object? I need to somehow combine that with my current object. So what I do inside here is say if there is no star part here, addition just returns a multiplication, that's an expression, I'm fine, right? But if I get into this block, this zero or more closure, I need to create an object of type addition and assign a left and right variable for it. So I'm going to go inside here and say addition dot op1 equals current. It always starts off with whatever that first object is as current. Now I'm creating a new addition object setting op1 to current. And then over here, once I get this guy, op2 equals multiplication. So I have that addition object is my current object now. I've set his op1, I've set his op2. I also want to set his operand. Just like that. Operator, sorry, his operator is plus or minus, his operands are the things on either side. Does that make a little bit of sense? Okay, and this is a common idiom you'd see in Xtext. We're going to do the same thing down here. We're going to say multiplication op1 equals current. So that's going to take whatever the current guy is and make him op1 of a new multiplication object that I'm going to return. That new multiplication object becomes my current. And then over here, op2 equals and operand equals. And if you prefer, you could call this left-hand side, right-hand side instead of op1, op2. Okay. Down here, primary has subtypes, variable ref, literal, and or he can return an expression which can either be a variable ref, literal, or addition. Okay. Questions so far? Okay. So this is how we factored out expressions. And I believe, oh, I don't have a browser open anymore, do I? Take a look at something I haven't looked at in a while, see if it's still here. Yeah, I have it right here. So underneath in javadude.com under articles, there's this converting a grammar from LALR to LL. And this talks about doing that left factoring. So here's like an example of the expression grammar that we talked about before. And then this talks about how to break it back down. I think I have a better discussion of it in my Antler tutorial. So if I look at the first Antler tutorial there, yeah, there we go. So all the way down here where it says expressions, I wonder if I have a table of contents at the top. So down in here I talk about how expressions work and how you use your precedence table to generate those individual subrules. And I go into it in a good deal of detail. So if you want a little bit more detail on that, let me see if there's a link there. No, I don't have a name on that guy, so I don't have it linked. That's a shame. I used to at one point. I used to have a table of contents on this, and somehow that must have gotten lost. So, but there's some information there, but then there's also that other article saying converting a grammar from LALR to LL, which will talk about left factoring, which is the biggie. It's left factoring and left recursion. Actually, left recursion is really what we're dealing with here for this one. So you'd want to take a look at that section. Okay. So questions so far? So we now have it, yes? This is just a special operation inside of Xtext. As far as I know, I think it's only used for this particular purpose. So it's I think they call it a tree rewrite because we're rewriting the AST here at this point. And we started off with the current AST pointing to multiplication, and then we're creating a brand new AST node with this curly brace. They might call it an AST rewrite. I closed my browser again. They've got some, if you just look for Xtext, they have a pretty good page for documentation. Yes?
Just out of curiosity, are you still recording? Because I haven't seen the recorder change. Okay.
Oh, when I do this, it's actually just at some point in time, well, now it's changing. But sometimes it just stays. Oh, yeah. So like, oh, it's still visible. Sometimes, yeah, it stays. If it's not visible, it doesn't look like it's changing. But yeah, anytime, feel free to let me know, because otherwise, yeah, I hate to lose stuff like that. So if you go to the Xtext main page, just if you search for Xtext, you'll find it really easily. They've got some really good documentation here. Some of it's a little thick, and by that I mean it's just kind of hard to get the feeling of. Why are they using a 3D printer for a bunny there? Let's do a 3D printer. That'll be part of this class. Let's see.
You're talking about using DSLs to program 3D printers?
Oh, that could be. Let's see. So assigned actions is what they're calling them. So that didn't say anything there. So the grammar language. Because I think the only types you can do are rewrites and defining explicit objects. Xtext leverages the powerful ANTLR parser. So here they're talking about this. So in this particular case, if you say the parens without a dot something in there, it just creates the object at that point. This is sometimes useful if you want to do some initialization on an object before it fills the details in. So let's see. So that's an unassigned. Oh yeah, the reason you want to do this here is that if you have expression and just said left equals this, it's going to create an expression object and set the left variable. If you have this unassigned action, it just creates an instance of operation that becomes current. And then when you say left, it goes into the operation as opposed to that expression guy. So that gives you a chance to set it up front. So this, in this case, is always going to create an operation object and say expression or operation.left equals that first guy, and then there might not be anything. So this is going to create basically a wrapper object around any type of sub-expression, whereas the approach that we were using, which was like this guy here where I say expression and then terminal expression, if it's only that one side, it's not going to create that extra wrapper object for you. Once we get to the operation.left over here, he says, oh, if I see I need to have the wrapper object, go ahead and create it and assign the left and then assign the right. So that's the difference between the two. Is like up here, it's always going to create that object, always wrapping that terminal expression, even if I don't need it. And this guy here is saying only create that wrapper if I had the plus sign between. Does that make sense? But I'm pretty sure that's the only things you can do with that. I'm not going to get into syntactic predicates. If you want an explicit wrapper for every level. So if for some reason that's easier for you to parse later on, when you're actually walking the tree, if it makes any difference for you there, maybe you cared that there was that intermediate step, even though you're not actually using it for anything. But most of the time I'd want to do the assigned action side here. Oh yeah, it's actually showing what the tree looks like here. So the tree actually has that extra wrapper operation all around it. Whereas here it's just, well, they're not showing you what the tree looks like. In this case, it would just be the int literal coming through. Okay, so that's the curly brace guy. And where is my... There we go. So now we've got a nice little expression grammar here. Yours is going to be somewhat similar to this. You're going to want to have them return component or container. So think about those as your types that you're going to have returned. And remember that container is a component.
So 5 is going to be rewriting for an Xtext?
5 is going to be two parts. It's going to be rewriting an Xtext and then doing code generation. So it's not just doing the interpreter again. So you did the interpreter for 4. The next one's going to be generating code that gets compiled and run at runtime. And the second half of this is going to be talking about code generation next week. Okay, so now we're going to take this little grammar here, and we're going to use this as an interpreter as well. Yeah, the other example was an interpreter as well because we're reading it in at runtime and then executing. So now that I've got this guy, let me compile him. So I'm going to run my MWE2, run as MWE2 workflow.
And xtext automatically swallows white space and ignores it.
Yes. Yeah, you don't have to explicitly set that up. If we take a look at the terminals defined here, so we'll see that white space, it says this is, it creates a terminal for it, but then it sets it up as a hidden token. When it generates the antler grammar under the covers, it just adds a skip rule to it. But these are the default things you get by default. So it actually has the comments, multi-line and single-line comments. And then this is just so they can catch anything else and treat it as an error. Now, I should mention the caret. If you have a keyword that you really want to use as a variable name, so if I want to have a variable name called var, I can say var space caret var. And caret is a little override that says, I know it's a keyword, but treat it as a variable name. So you can do that if you really want to. There's some times when that's actually pretty nice to do. Try to minimize it when you're using it. You don't do that in the grammar, you do it in the actual implementation. So we'll see that in a second here. Did I run that? Oh, I ran the xtext. So the generation came up okay. I'm going to go ahead and say debug as Eclipse application. Let's create in our test here a new file, test1.expressions. And let's see if we can do something here. So I'm going to say var x, var y, x equals 42, y equals 10. And apparently I have done something that it does not appreciate. It doesn't like that equal sign. Let's take a look at our grammar. Oh, it was expecting a variable definition there as opposed to a reference. Actually, that should be a variable ref, shouldn't it? Either way is fine. If by saying variable ref here, I'm actually going to have an object that wraps that reference. At this level, I could directly have the reference to it by saying variable. The reason I needed it down here was for the subtyping. Otherwise, if I had the explicit guy here, if I tried to say variable, this actually isn't a type. So I could say var equals variable, but then it's going to say, oh, you know what? Now you're saying primary, set var on that. So now I'm going to have a primary object with a var section as opposed to something explicitly saying I'm a variable reference. So using variable reference there is a little bit more clean. And up here, I can either use a variable reference, which would mean I just have to go one level deeper when dereferencing it, or I can just directly look at the link there with the brackets. Did I close my nested? No, I didn't. Let's close him.
So you could have said z equals 10 in that previous buggy instance, right?
In the previous buggy instance, I would have actually had to say var x equals something because it was expecting a variable, and I would have had to say the var in front of it. But the problem would be then if I want to try to redefine it and said var x again, it's going to say, Actually, I think the default is you can actually have multiple definitions with the same name. I might be wrong on that. I'd have to take a look. It depends on what's set up in the MWE2. Yeah, the names of unique validator is turned off right now. Let me turn him on and rebuild that. It gets much more interesting when you deal with scoping. And by interesting, I mean pain in the butt. It's really neat the way they do it, but I mean it's tricky to get the scoping right. Yeah, scoping in general is just a pain. It's great stuff. I mean, I'm glad that somebody came up with the idea of scoping, but yeah, it's a pain. Okay, so now we got that he built locally. I'm not running another copy. Good. Okay, I will go ahead and launch him. There we go. Now he's happy. And so in here, let's say x plus 3 times y minus 4, something like that. And there we go. So we have a nice little expression grammar. If I hit my control space, it's going to give me options for what I can choose there. I can choose x or y. I could choose a numerical value, and they're just saying, oh, I'll just give you 1 as the value that you can choose. And at any given point inside here, it'll tell me the next types of things I can type in. Now, why would it be saying that I could put an x there? Oh, so why can I do that? Why is that valid? What does that mean? It's the same as that. I don't have any type of delimiter separating expressions, so I can have one expression following another. I mean, I could have x or x, 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 and that's perfectly valid. What's going to be the result of this thing? If I ran this right now, what should I see as my result?
X.
Which is 42. So I should just get 42 out, because it's whatever that last expression is. So yeah, this is one of the perils of not having a line delimiter or a statement delimiter. You can have things like that, which is like you thought, oh, that should have died. It's like, no, actually, it shouldn't have. Okay, so now we have, there's our nice little expressions. I'm going to take that same file. Let's copy it over to hell here and paste it in there. I'm going to create a test3, which did this update to include all the other stuff? Oh, no. Oh, because it's in a different, no, duh, it's a different project. So, yeah, actually, let me not put him there. Let me create a brand new, I want to do an import. So close him, import, expressions parent, Gradle, blah, 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 blah. Does he look like he's okay there? So let's see if I have to create this module twice again. Test 1. I bet it's not going to create those directories for me. And it did. Nice, consistent piece of crap. Okay, so now we have our source main Kotlin. Let me copy over from the other project. So I'm going to copy that guy. Going to copy the data file. And let's do some hacking around to make this work. Yes, to refer to the data types, that would be helpful. So test build.gradle. Say compile project com.javadude.expressions. That's what I called it, right? I did use an S this time. Okay, good. He looks happy there now. And so now inside here, don't need command channel or get next state or controller. We'll throw all that crap away. Oops. Ah! Another thing I hate about IntelliJ. Okay. Didn't I just delete that? There. Very gingerly approach that. Okay, so instead of state DSL standalone, I'm going to say expressions DSL. DSL standalone setup. There we go. Injector, we're going to change this one to be test1 and what did I call that? Test1.expressions. And the top level guy inside here was what? Seriously? Why are you not switching to that window? I think you're right. I think it was model. There he is, model. Yep. Am I in the right place? This is the state one. I'm going to close the state one just so I don't accidentally start editing the wrong one here. So this is going to be model. Okay, so now we have to deal with how do we evaluate that expression. So inside there we have variables and we have statements. Okay, do I need to do anything with the variables? Well, we don't have values yet, right? I could assign them a null, but does that matter? I can just ignore them. They're just there as a necessity for when you're working with the language so that you can have references to them. So we can just ignore the variable declarations. And then we're just going to, in our statements, when we hit assignments, we'll deal with those. So let's take a look at what we got for types here. Statements are of type statement. That's kind of high level. I can say walk through them all and then call an evaluate function. The evaluate function is going to take them as a statement as the type. So at that point, I got to figure out, well, what do I want to do? It's going to depend on the type of the actual object, right? So I'm going to have to do runtime type identification on these to see what actually these objects are, because unfortunately there's no dynamic dispatch in Kotlin or Java. So what we're going to do is a couple ways we can approach this. We can set it up so that I have an evaluation method that says when I evaluate a statement, let me take a look at the types. If it's an assignment, call evaluate, casting it to assignment. If it's addition, call evaluate, casting the statement to an addition. And then go down a level deeper. If it's an addition, it's really an expression, right? It could be any type of expression. So then inside there, I got to figure out what type of expression it is. Or I could just have a single statement function that checks all the types in one block, which I think is cleaner for this example. I'm going to show you kind of both ways depending on how much time happens. You can break them down further to kind of give you that nested dynamic dispatch, because the dynamic dispatch is very explicit in our code. So inside here, let's create an evaluate function. Let's do it the explicit way first. So I'm going to start off with evaluate, taking in a statement. You know, to make this easier, I'm just going to call it x from our expression DSL. And then inside there, I'll say when x is assignment, evaluate x. When it's a addition, is that the other one there? Yeah. Evaluate x. And this is going to actually return something. Oops, come on. And we'll say x : class.
But addition isn't a superclass of multiplication, right? You have to handle, if you're just handling addition, you have to handle multiplication and...
Actually, I should be passing expression there. I shouldn't be saying addition. Good catch. Okay, and then I'm going to do the same kind of thing here, saying for an expression, he can be an addition, or he can be a multiplication, or he can be a primary. Didn't I call it primary? Oh, I'm guessing it just threw that away. Does it? Because there's no place that needs it as a supertype. That's interesting. I'm not explicitly using it anywhere. It's just being used as a grouping for these guys who are all being returned as an expression anyway. So variable ref literal down there. Something like that. And then I can come down and say, oops. For each individual one here, this is going to be for addition. And what is he going to have to do? So we're going to say evaluate x dot op1. Oops. Return when x dot op thank you. That would never happen. Plus, I guess it's just because I haven't finished defining everything yet. So we got him. Let's do multiplication. Times divide. And then we had variable ref. And it means we're going to need some variables. Val variables equals mutable map of string integer. Oh, yes, yeah, we're in Kotlin here. That's what I get for writing this stuff in Java earlier today. So in here, we'll say variables sub x dot variable dot name. Otherwise, throw illegal argument exception. And we'll say variable dollar x dot variable dot name not or has no value. Something like that. I could actually just go whoop. Oh, that's why it didn't like it. I still have my return on there. And I still got the return in there.
So, what do you like? You just like buying yourself one line?
Basically. Well, there's two things. I'm buying myself the line and not having to specify the return type.
Right, but doesn't that make it harder to read later?
And 601 half dozen the other.
Do you have to encapsulate your when cases in curly braces now?
So because of the recursion there, I have to specify the return type anyway, so this doesn't buy me anything now. Oh! That happens once in a while.
How is that not a thing with the multiplication?
It caught the first error there
Oh,
in the when. Yeah, it's one of those. Okay, so variable ref, and the last was literal, right? And then I have to do the assignments. So literal, and this one's going to be nice and easy. X dot value. And so the last one's going to be the assignment. And we're going to treat this as an expression just to make this simpler rather than having separate statements versus expressions. Everything's going to be an expression here. So we're going to say variables sub x dot variable dot name equals evaluate x dot value. And actually I wanted to return that. So say val value equals, do that, and return value. Or what I could have done is return actually let's not use apply, let's use run. No. Let's let. No, I wanted to return also. That's the one. Also is the one I was looking for. There, that didn't really save me anything, now did it? I mean, it saved me an extra variable. But anyway, so can I just do the equals? Oh, for this one? Boom. Boom. This one will work. And then boom.
The last will work too, but
Yeah.
What does that body? Just makes it look a little better?
It's really, it shortens it up a little bit and removes the return type, so you don't have to explicitly type it in two different places. Kotlin, the design behind Kotlin, they were really picky on trying to get things so you don't have to be redundant. And it's like if you know the value of x dot value, it can infer it as opposed to you having to type it in explicitly.
the only time I like it is when it's actually like something short like that, where you can put it on the same line. Otherwise, you end up not.
I really like it when they're short like that.
Yeah.
Yeah, that one I can see. The other one I'm like, okay,
Yeah.
take it or leave it.
So if the return type ever changes, then it would automatically trickle through the rest of your code instead of being updated in both places.
That's actually a good point. Yeah, if the return type changes, which could be plus, could be a minus, depending on what you've done. But obviously,
When stuff like that
yeah,
happens.
when you have recursion things like this, I think if I remove them now, it'd be okay because I've defined all the evaluates. I don't want to mess with it, but I think it would be able to evaluate now, knowing that these are all ints. Yeah, he says he's int. He says he's int. I think he'd be okay now because he can infer the types because I've covered all the bases.
Wish it did that light gray, like what type it is, versus marking type.
That would be nice. It's like when they put it in places where sometimes I don't care, and then other times they don't have it in places like here, and I think sometimes I've seen it put here.
Yeah, because I just,
Yeah, like that's where you want to know what the return type is without
Yeah.
having to hover over it.
And without having to type it in. Yeah. Okay, so this evaluate is never used.
Because you never went.
Oh, I never called it. Okay, so now what we're going to do is now that we've defined, we don't need a state machine. That doesn't. So let's call this model. And so now I'm going to say model dot statements for each, and then let's have a val result equals 0. Result equals evaluate. Oh, they're not in the companion object. Boom. That should make it visible now. Evaluate it. And then return result. And I should say var up here instead of... Oh, I just wanted to print, didn't I? Println result. There we go. Something like that. And let's get that guy out of there. Are we looking good now? And it's just complaining these can all be private.
You can fix them all at once.
Oh, I can?
Yeah. Go right arrow, and then down one.
Ooh, okay. Boom. That speeds things up a little bit. So now we should be in pretty good shape here to run this guy. So test one expressions, is that actually the name? Yep, let's try it. $68. I don't know if that was right or not, but so 30, 72 minus 4. Yep, that looks good. So yay, that worked. So that's an example of a little bit more complex situation in Xtext, but a situation that comes up once in a while. So whenever you have something that's going to be nesting recursively like that, which I'm pretty sure is going to happen in your assignment. I got to run some examples. I'm pretty sure that's a problem there.
Well, are we going to be doing that? Oh no, we're not doing this. We're doing that.
Oh, actually, you do need to have expressions. So you're going to have expressions like this. They're going to be kind of similar.
Plus the container.
And I think the container might need it.
You might not have to do it that way, but the ways I've done it in the past several assignments.
Actually, I think you're going to be okay because the I have to think through it again. But you're basically going to say returns component, for example, there, and so that'll be kind of your super type for all of your all of your containers and all of your buttons and things like that.
Or maybe not, but maybe in something else.
Yeah, I mean widget. I mean whatever you want to call it. That might work there. Okay, so that seems to work pretty well. Let me do something real quick on validation. So I'm going to close my nested guy. So we see that we have inside here this validator that was created by default. And I'm going to start. Now this is actually using extend as its language. The syntax is a little bit different from Java, a little bit different from Kotlin. So you can give a class of error messages that are going to appear so that when the user is looking at the errors in Eclipse, they can sort and filter and decide what they want to do with those. So let's go ahead and say invalid name. That'll be fine. So each of your checks is going to have a check annotation on it. That's this Xtext validation check. And you can define the method whatever you want. So let's say that all of our variable names have to start with a lowercase letter. Variables start with lowercase. And so I'll say inside here, variable, like that. And I'm going to say if character is uppercase, it's nice because it's almost the same thing. Variable name char at 0. I'm going to make that an error.
Do it or bang.
I'm sorry?
There's a bang.
Oh, thank you. Name should start with a lowercase. Let's make that say variable name. We'll import him. And this is going to be variable name. So this is a reference to the, I believe they call them feature that you're trying to look at. So we're going to take a look at the this is not passing in. I don't know if this is going to put the error in the right spot, but this is saying that I should highlight the name part of the variable. So I'm guessing that the default for error here is to use the element that was actually passed in. It's been a while since I've done this one. So now that I've defined that, I can start up my nested Eclipse. And if I come in here and try to use an uppercase letter, variable name should start with lowercase. Ooh, ah. And then down here, couldn't resolve reference to variable y. Yay. Now if I come over here and try to do the y, uppercase y, it's going to work because the variable's defined. It just has a bad name up here, which my validator is saying, nope, can't do. And when I come back here, boom, everything's back to normal. Let's try using the validator in IntelliJ, which I have never tried. I copied some code in here that supposedly works, and it sounds reasonable enough, and it's Java code. So let's uncomment this and see if I cut it and paste it. Oh, I thought it would have said it looks like Java. Okay, so let's see if we can fix this up. So I'm going to make this be val validator.
Can you just like select it? And is there a context menu thing? Convert me to Java or to Kotlin?
You can convert the whole project,
That sounds scary.
or you can convert the whole class. I don't know if. I think you have to actually select the. Oh, it's under here. Convert Java file to Kotlin file. But usually when you paste in Java code, it recognizes it as Java and says, do you want to convert it? Which is why I was thinking I could get away with cut and paste. You know, cut it and paste it back. And then val issues. Check mode, cancel indicator. Oh, duh. When severity error. Println, blah, 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 blah.
Println is one of those like auto imported by Kotlin
Mm-hmm.
things.
And it just calls system out println behind the scenes. And is he wanting to be exhaustive? Is that what he's talking about? Let's put in else.
Question marks.
Which, of course, I probably could have just done this to start with, right? It's kind of a silly example wherever I copied this from. Why are they explicitly... Maybe they just wanted to say if you want to handle them in different ways. But, yeah, kind of a silly thing there. So I think... And this actually, what I can do is... Let's have a little flag on here. Val is evil equals false. And so in here I will say, if there's any errors, is evil equals true.
Or just get rid of the when. Oh no, because now you're treating it differently.
Yep. And I called it a val, didn't I? Man, I'm so used to typing val instead of var. And then down here I can say, if is evil. I actually want to...
Do we want to validate first?
Yeah. Might be a good idea, huh? Wait a second. I'm checking the resource. That's good. Okay. So this guy here, I'll make this if not is evil. Else println execution aborted. So there. Okay. So let's try that. First of all, we'll run it when everything should be okay. Well, he took a little while that time. And now let's modify it. Uppercase Y. Let's try running it again. Yay! Now he didn't say where it is. That would probably be helpful, huh? So I'd be willing to bet I can say $issue dot column and line number. Yeah, so line number colon $issue dot column. And we could probably have the code too, it looks like. That was a little bit farther than I thought it was. Shoot, I wanted to do this. I'm fixing up the stupidity there. And then evil. Can I do that? No, I guess not. I don't think they have that operator.
I tried that.
If issue severity equals severity.error is evil equals true.
I actually think it's interesting that there's no ternary operator in Kotlin, given
Yeah.
their
Their terseness, yeah.
yes.
I think somebody's decided they hate the ternary operator, and it's like Elvis is ternary just compressed. You know, it's
And you have the if assignment, but that doesn't get me any like.
yeah,
less-
that if assignment drives me nuts, being able to having to explicitly spell it out. Okay, let's try that, and that should give us something a little bit more meaningful. Well, that's kind of gross looking. Invalid name, variable name should start with a lowercase. Oh, that's the actual, not code as in code in the file. It's the ID, the error code. Ah, see, I thought it was actually going to.
column or interesting, but yeah, the error code.
I thought there was a way that it gives the. It might be data. There's offset. Was a message as well. So it might be data. I don't know. I'm going to skip it. But I think there's a way you can explicitly get the code and then highlight which part of the line it is or something like that. But you get kind of the idea here. So that worked fairly well. Execution aborted. So there. And if you actually did it right, you don't have that issue. No suggestions. Yeah, one thing that is really not good here is if, oh, it actually worked this time. Oh, no, I'm thinking the other stuff. The language server. So I'll try doing the language server next week to show you what that looked like. The language server does some really stupid things inside IntelliJ. Like when you do code assist, it puts the cursor back before the word. So if I started typing V code assist and it puts in var, it jumps the cursor to before the word var, which is exactly what you don't want it to do. I mean, it's like, ugh, maddening. Okay, so let's see. Any questions on any of that? Any questions on the homework? Okay, so homework is due next Monday night. Sounds right? Okay. Have a great weekend. I'll see you next week.